Alright guys, so we're starting with chapter 3. So we're continuing with our univariate data topic. This chapter is going to focus on measures of dispersion or spread of the data. Alright. So why do we want to talk about the spread and dispersion of data? With most data, we'll find the average, which can be useful in summarizing data, but they don't tell the whole story. We need to consider how widely the data is spread or dispersed. Another one way that we've done previously of measuring spread has been the range of the data. So the highest data subtracting the smallest data, but that's only telling us that's only taking into account two scores. For example, here are two different types of data, each with 40 data points. The range is both 30, but their data spread is very, very different. All right, so we can use mean deviation. So this considers how each of the scores deviate from the mean score. So how far away is each score from the mean? So this is Team A. We've got 5 players and 5 recorded heights. Their average height is 184 centimeters. So now we're going to find out how far away are each of these heights from from the mean. So we just subtract it. So we've got from 211 to 184, 27 centimeters away from the mean. These two scores are both uh, they're both at the mean, so they're 0 centimeters away. And then we've got two scores which are below the mean, so 12 centimeters and 15 centimeters. So once we know what the deviation from the mean is, we can use that. So if we added up all the deviations. I spelled that wrong. If we add up all the deviations, the answer would be 0 because it's the mean. But instead, we can find the mean deviation. We'll ignore the negative signs, okay, just here, and we'll average the absolute values of the deviations. Oh, wait, down. So we add up all those deviations and put that over 5, which is our how many scores we have, and our mean deviation of the heights is 10.8 centimeters. All right, we could also use standard deviation. So instead we can square the deviations and find the average of these square deviations, which is called the variance of the scores, and then square root this variance. So for example, if we had these 5 numbers, 4, 7, 10, 13, and 21, we need to first find our mean, which is 11. Then we go through and find the deviation from the mean. So each score subtracting 11 and then squaring it. All right, so we've got 4 minus 11 squared plus 7 minus 11 squared. Oh, wait, chill out. 10 minus 11 squared plus 13, etc., and then over 5. So our variance would be 34. We still need to square root that. So our standard deviation is the square root of 34, which is 5.83, corrected 2 decimal places. So the scores have a mean of 11, a variance of 34, and a standard deviation of 5.83. All right, so we've also got two symbols that you should know. So standard deviation symbol is sigma. The lowercase is kind of this O with a little curl on the end, and the uppercase is kind of like a funny looking Z or an E. All right, so lowercase sigma and uppercase sigma. So even though finding the standard deviation seems more complicated, it's actually more commonly used measure of dispersion in data analysis. And we're going to focus on this one. So then there's outliers. So standard deviation is a measure of spread, and most data lies within 3 standard deviations of the mean. So our average minus 3 standard deviations, and our average plus 3 standard deviations. 2/3 of the score would lie within 1 standard deviation of the mean, so minus 1 standard deviation or plus 1 standard deviation. Any data that's far away from the others, so outside of the 3 standard deviations, is known as outliers. These extreme values can have a big effect on our standard deviation. So what is up with my spelling mistakes today? Sometimes we might determine the standard deviation with and without the outlier and then comment on the difference. All right, and then with group data, so for example, we're doing our works with histograms. So group data into intervals can be used to estimate. So for example, if you have your grouping maybe from 20 to 25, then 26 to 30, etc. So we can actually use these as an estimate for standard deviation by selecting the midpoint of each interval group, so halfway, right in the middle of each interval group, and then using that value for standard deviation.